students, we saw a little bit of the periodic table in the last video, and I hope you are ready for the second half of the periodic table. Okay, some more questions and some more ways how to crack the correct answer. Okay, now the question goes, the number of electrons in the valence shell of a halogen. Remember, we have to learn what are the groups that we need to know. We need to know group 1, 2, 17 and 18. And this group 17 is what these halogens are about. Okay, it starts with fluorine, chlorine, bromine, iodine, of course astatine, but it's radioactive, so we don't consider that. Now when you come to this, when you write the electronic configuration, fluorine goes like this, 2, 7. Then this is chlorine with 2, 8, 7. And then bromine, of course we don't have it in the syllabus, we don't need to worry about anything above atomic number 20. Alright. Now here you see all these halogens have how many valence electrons? 7. Okay, here now let's go back to this point. What does it say? Elements in the same group, in a group, will all have the same number of valence electrons. These are important points that we need to note down. So that means if fluorine has 7, chlorine has 7, all halogens have 7. So 7 is the right answer there. Okay, so we mark 7 here. Alright, next, across a period, ionization potential, will it increase or decrease or remain the same? Okay, the most important points that we noted down in the previous video, that's why you should keep track of it. It says that ionization potential will increase across a period. So the answer for this one is it increases. Alright. Next question. An element A belonging to period 3 and group 2. See here you have a point here. The number of periods denotes the number of shells. Okay. Now come back. Element belonging to period 3. How many shells it would have? 3 shells. So the answer, first answer is there. Group 2. If it is belonging to one group, group 1 would have 1 valence electron, 2 would have 2 valence electrons. 17 is halogens which have 7 valence electrons, and group 18 has 8 valence electrons. Only these 4 you have to remember. 1 and 2 is normal. 1, 2. 17 has 7 and 18 has 8. Now come back. What will be the correct option? Is it 3 shells and 2 valence electrons, or 2 shells and 3 valence electrons, and 3 shells and 3 valence electrons? So don't look at this distractors. You remember how many shells could it be there if it is period 3? 3 shells. So the first answer is over. Group 2. So 2 valence electrons. So what's the answer? It would be 3 shells and 2 valence electrons. That should be the answer. Where is it? It's the answer A. So A is the correct answer for this question. Alright. Next we go to a slightly different one. This is in fact linked to the chemical bonding. Element with atomic number 19 will most likely combine with an element atomic number 17, 11, 18 and 20. Okay. Now how to find this out? The best thing to do is to write the electronic configuration. Always children remember to write the electronic configuration for this. Now with atomic number 19. Okay. So this would be 2, 8 in the second shell, another 8 in the third shell and 1 in the fourth shell. So this is the electronic configuration of 19. Now let's go to 17. So A, option A is 17, which means 2, 8, 7. Okay. The option B is 11, which means it's 2, 8, 1. Okay. C. C is 18, oh no, let me put it here only, 18, which means 2, 8, 8. First shell will have 2 electrons, second would have 8, and the third shell has 8. Then option D has 20, 2, 8, third shell has 8, and fourth shell has 2 electrons. Now remember, if the valence electrons are 1, 2 and 3, they are metals. If the valence electrons are 5, 6 and 7, they are non-metals. This we should remember. Now let us come back. Now this first element has 1, that means it is a metal. A metal will combine only with a non-metal. A metal will never combine with a metal. Now let us see. Is this a metal or a non-metal? It is a non-metal. Okay. Is this a metal or a non-metal? It is a metal. If it ends with 8, it is an inert gas. 2, again it is a metal. So probably this element would combine with a non-metal, that is A, atomic number 17. So the answer for this would be A, atomic number 17. Alright. Next, the element in period 2 with 0 electron affinity. We have here all inert gases have 0 electron affinity. But here we have all the 3 gases that are there are inert gases. So we need to know the order also. So that is where we need to learn the order of this group, that is group 18. Helium comes first, neon comes second, and argon has 3 shells. Now which one in period 2, the one which has 2 shells would be period 2, and that is nothing but neon. So neon has 0 electron affinity and it belongs to period 2. Alright. Next, the element with 4 shells and 2 valence electrons. Now this will help us, right? As we go, this is the third shell, and the last shell would have potassium and calcium with 19 and 20. So here, 4 shells would be sodium, no, magnesium, no, calcium, yes. So the answer for this question is calcium with 4 shells and 2 valence electrons. Okay. Next, the smallest atom in the third period. You have 3 options. You have chlorine, you have sodium, you have argon. Okay. Now here, what does this say? The smallest atom in a period is a halogen. Why? Actually, atomic radius will decrease, right? From left to right it decreases, but it decreases up to the halogen, and then there is a force of repulsion on the inert gases. So inert gases have greater atomic radius compared to the halogens because of forces of repulsion. Now coming back here, so which one would be the smallest? It would be A, that is chlorine. Okay, so chlorine is the answer here. Which of the following electronic configuration has the highest ionization potential? See, what did we learn in the previous video? That ionization potential increases across a period. And what happens across a period? The valence electrons also increase. Okay, it starts with sodium, for example, would be 1, then magnesium would have 2, aluminium 3, silicon 4, and so on up to 8. So the valence electrons increases. Okay, here as the valence electrons increases, ionization potential also increases. Now let's come back. This has 1, so ionization potential is less, 3, 6 and 2. So among this 6 valence electrons, this element would have the highest ionization potential. that is the energy required to pull an electron from the outermost shell or the valence shell. Naturally, when there are 6 electrons, it's not easy to remove one electron. When something is all alone, it's very easy to remove. Okay? So, C 2, 8, 6, that is the element with the highest ionization potential. In increasing order of the number of electron shells, what do you mean by that? One element would have only one shell, the next element would have 2, the next will have 3 and 4 and so on. So what is the correct order? Only 3 of the inert gases are there. Alright, so this is where we should remember the order. Inert gases start with helium, that is the first inert gas. Okay, the next one is neon and the next one is argon. Only 3 we need to remember because only up to atomic number 20. So helium has 2, neon has 10 atomic number and argon has 18, which means this electronic configuration is 2 here, this is 2, 8 here and this is 2, 8, 8. This denotes the number of shells. This one has 1 shell, this element has 2 shells, this element has 3 shells. So coming back here, in the order of increasing order of number of electron shells. So what would be the correct one? Helium first, neon next and argon last. Where is that order? It is C. So the answer for this question is C. Okay, helium, neon and argon. So that's the answer. So this is how you crack the solutions for your multiple choice questions on this chapter. Okay, if you like this, you can share it with your friends and subscribe to my channel and stay tuned for more videos on chemical bonding and also the other chapters. See you then.